Ever wondered why a football curves when kicked from a certain angle, or why a fountain's water arcs the way it does? The answer lies in a fascinating concept of physics known as projectile motion. Picture this. A ball gets thrown into the air at an angle. The path it follows, the speed at which it travels, and the point where it lands all come under the intriguing study of projectile motion. This concept is not just theoretical physics, it's an integral part of everyday life, seen in everything from sports to space travel. Starting with the basics, what exactly is projectile motion? It's a form of motion experienced by an object or particle that is thrown near the Earth's surface and moves along a curved path under the action of gravity. This path, known as a trajectory, takes the shape of a parabola. The initial force propelling the object into the air, the angle at which it is thrown, and gravity are the key factors determining the trajectory. The object is subject to two forces, horizontal and vertical. The horizontal force propels the object forward, while the vertical force, gravity, pulls it downward. Here's where it gets interesting. The horizontal and vertical motions of a projectile happen independently of each other. That means the horizontal speed remains constant, while the vertical speed changes due to gravity. This independence of motions is what makes the path of a projectile a parabola. Now onto the nitty-gritty. How does one calculate the aspects of projectile motion? There are four main elements: initial velocity, time of flight, maximum height, and range. Each of these has a specific formula, all of which derive from basic kinematic equations. Initial velocity is the speed at which the object gets thrown. Time of flight refers to the total time the object is in the air. Maximum height is the highest point the object reaches, and range is the horizontal distance the object travels before hitting the ground. The fun part of projectile motion is that it's predictable. Given the initial velocity and launch angle, one can calculate the time of flight, maximum height, and range using the formulas. This predictability is what allows NASA to accurately launch spacecraft and land them on other planets, or a football player to kick a ball into the goal from a distance. To wrap it up, projectile motion is a fascinating aspect of physics that governs the path taken by an object thrown into the air. It's defined by the initial force propelling the object, the angle at which it's thrown, and the force of gravity. The path, or trajectory, is a parabola due to the independent horizontal and vertical motions of the object. The key elements of projectile motion are initial velocity, time of flight, maximum height, and range. Each can be calculated using specific formulas derived from kinematic equations. And the most exciting part? It's all predictable. Whether it's launching a spacecraft or scoring a goal, understanding projectile motion is crucial. So the next time you witness a curved free kick in a football match or watch a rocket launch into space, remember, it's all about the science of projectile motion.